Hi everyone, my name is Agatha and I am a part of the marketing team at MightyCon, and I would like to welcome you to our webinar on fire design for beam hanger connections. I'd like to draw your attention to the panel on the right-hand side of the screen. In the panel, you will find a handout section with a copy of today's slides available, and those seem to work in Firefox. Unfortunately, Chrome seems to be having issues with it. You can ask questions throughout the presentation and we will answer them as soon as we can. We will try our best to answer them throughout the presentation, but if there's any we miss, we will be sending a Q&A in the follow-up email where we will be answering all of your questions. So without any further ado, I'd like to kick things off by welcoming Netta, one of the engineers on the technical support team at MightyCon. Netta, over to you.
With the popularity of tall mass timber buildings and the recent code changes in favor of these taller buildings, we have to ask, is your mass timber connections fire rated? And are they compliant with the new code changes? Today, we'll go over solutions that are both fire rated and fire tested. Hi, I'm Netta Naderi, and I'll be your host today for this presentation. I'm one of the technical advisors for MightyCon Timber Connectors. We are a specialized mass timber connection system supplier based right here in North America. Today's webinar is split into 3 parts. We're going to go over the beam hanger system and its fire testing. We'll point out some of the code changes and how that affects the fire design of mass timber connections. And finally, we'll end the presentation with a fire design example. When we usually say fire-rated connections, we mean using drywall and wood covers over our connections. Regular connections like the one here on the right has a wood plug or an extra piece of wood at the bottom. Other connections include pre-engineered connections that have been fire tested. So this is the inside of the First Tech Credit Union project in Oregon, and they've used our concealed pre-engineered beam hangers. So you can see them all the way through this office setting here. For those tuning in our webinar for the first time, back in September 2018, we went over the beam hanger system in a little bit more detail. That webinar answered 3 questions. What is the beam hanger system? Why we should use them, and how they are used. We'll go over the answers to these questions briefly. So what is the beam hanger system? It is a simple pre-engineered solution for mass timber. As of right now, there are 3 main types of beam hangers. So the first one is the Gigant. It's the smallest hanger, and it has a capacity range between 1.2 kips to 2.5 kips, and that's all in ASD value. The Rikon, which is our most popular system, can withstand loads between 4 kips and 17 kips. So this system has the capability to be used in a double and staggered configuration, and that increases the connection capacity overall. And finally, the third one is the Megant system. This is the biggest beam hanger, and it does have a little bit more components to it. So like the bottom and the top clamps, and they'll have a rod running through the connector. So it can withstand loads between 8 kips to 33 kips. The beam hanger system is pre-engineered because they have tabulated design values. So you can see a picture of the new beam hanger guide, which is out. It has clear and detailed installation instructions and also gives you all the capacity values for these different beam hangers. So all of these beam hanger systems also have installer-friendly tolerances, which makes it easier to be pre-installed. That allows it to have simple and repetitive installation in a controlled work environment, which allows for superior quality control. So you can choose to have an experienced worker do the installation in a warehouse like this one here, where the conditions are known and they're much safer for the workers. This leads us to the drop-in assembly. If the beam hangers are pre-installed off-site, they can just be dropped into place at the job site. This way, crane time is reduced, not many workers are required for the assembly, and no power tools are used. Let's quickly look at the cost of these systems compared to a custom connector. At first, the hardware cost might be a bit more, but when you add the engineering time, the detailing, the installation, and the on-site work, you can start to see the cost-effectiveness of the beam hanger system. But where the beam hanger really shines is if you need a special connection or if you need a connection that's fire rated. We'll see later in the sections, because we've already done our testing in the US, you don't need to do extra work. So all of this makes using the system much simpler than a custom connector, which in turn makes it cost effective. The beam hanger system, like we saw in the picture of the first tech, it can be fully concealed. The fully concealment is not only providing the best aesthetics, but it also helps with the fire design and fire rating of the connection. You can see here, you can house the connection in the girder or the secondary member, or you can house it in the purlin or the primary member. And if you have narrower purlins, you can also do a concealed configuration. So here just shows the side view of the concealed options, and you can see that it's super easy for the drop-in assembly. So let's go over our first My Tip for this presentation. We strongly recommend placing the beam hanger connectors at the bottom of the beam. So for example, if you place it closer to the top, it'll act as a bracket. So right here. And like a bracket, it can create a virtual notch, which means that you have to use reinforcement screws. So right here. If you do use reinforcement screws, you have to make sure that the screw head is countersunk and the hole is plugged. And if it's possible, you can try to install it from the top. So we recommend placing the connector at the lowest, most 30% of the beam depth. So that line, the red dashed line here, represents that 30%. We'll see later in another My Tip how this affects the fire rating. One of the biggest reasons why the beam hanger system is considered to be a strong and simple solution for mass timber is that it's a tested solution. So we've done a lot of testing in North America with USA and Canadian universities and companies, but the most important one is the fire testing. So we've done a full-scale, fully loaded fire testing in San Antonio, Texas, and that was in partnership with the Softwood Lumber Board, AROB, and DR Johnson. And the Southwest Research Institute published a separate report, and it certified the beam hanger system with 1.5 hours of fire rating. Let's look at the testing a little bit more closely. So the testing was all done complying with the ASTM standards. A constant load up to 16,000 pounds or 73 kilonewtons was applied to the configuration. Originally, the test setup was designed for 60 minutes of fire, but we saw that we can actually push the test to 90 minutes. And the configuration that were tested were the single Rikon, the double Rikon, and the McGant connections. So this diagram actually shows the test setup better. The connections were housed in routed sections in the column, and then the other connector was placed at the end grain of the glulam beam. And then we had a 5-ply CLT panel attached to the top of the glulam beam. Just as a side note, we applied fire caulking around the connector before they were installed, but we'll see in a picture closely how that really affected the char layer. So all of this was to mimic a typical office office building grid, and so the sizes of the beams and the columns were of commodity stocks used in the market. And to monitor the heat propagation during the test, there was 8 relevant heat sensors. So the relevant ones are the 2 that were placed 1 inch from the edge, and then there were 2 more that were placed deeper into the beam, 2 inches. And then there were 4 right at the connector themselves. So this picture just shows the real world configuration. You can see the beam, the column, and the floor panel, and this is after it was removed from the furnace. This chart here shows the temperature versus time for the single Rikon over 60 minutes. So this blue line shows the furnace temperature. It started from 0 and it went all the way up to 1,000 centigrade or 1,800 Fahrenheit. And just for reference, wood's auto ignition temperature is approximately 400 centigrade. So these gray and yellow lines show the heat picked up by the sensors. So this one is for the 1 inch from the beam edge, and this one is 2 inches or deeper into the beam. You can see that the sensors that were placed only 1 inches from the beam edge picked up heat faster, but the ones that were deeper in the beam picked up less heat. This shows that adequate wood cover is crucial to the fire rating. And if we look at the temperature right at the connectors, we can see that the temperature is staying constant and it's not getting much hotter. And you can say it's a pretty cool connector. So as mentioned, the tests were originally designed for 60 minutes based on the codes, but then it was pushed to 90 minutes. For the tests that were done until 90 minutes, the wood cover was slightly under the required thickness from the NDS and the CSA 086. But you can see for an example here for the Nagant connectors, the screws on the outer layer are in the char, but we didn't see any damage and there was no failure observed. We see from the testing for the design of beam hanger systems, the codes actually provide a more conservative approach. So if we take a closer look at the applied load, we see that there was no sudden drop. So this one was done for 90 minutes. So we can conclude that the assembly has sustained the whole load from the fire test. And for deflection, we see at 60 minutes, the deformation was minimal. So I mentioned that we use fire caulking around the connectors. If we take a look, we see that it doesn't really appear that the fire caulking had an effect on the char thickness. So here where we use the fire caulking and where there wasn't used, the char's thickness is pretty constant. So to wrap up this section, we went over what the beam hanger system was. It was a pre-engineered, pre-installed, and cost-effective solution that can also be concealed. It was also fire tested and it was certified for 1.5 hours of fire rating by a third party in the United States. Now let's see how fire design is done currently. In Canada and the US, the NBC and the IBC building codes lay out the fire design requirements. The NDS Chapter 16 and Annex B of the CSA 086 provide the design steps for the elements and the connection fire design. A good resource is the American Wood Council's Technical Report 10, which essentially acts as an appendix to the NDS, but it's widely used and recognized in both countries. So if you go to Annex B of the CSA 086 for the Canadian codes, you can see that it provides a one-dimensional char depth, and it's using a linear char model. And what do we mean by a linear char model? So from the many experiments that were done, it was concluded that the charring of the wood is actually nonlinear. So over time, the char acts as an insulated layer and prevents the wood from further burning. So in a linear model, for this blue line right here, in shorter periods of time or like less than an hour, the char layer is underestimated. But for longer periods of time or more than an hour, it's actually overestimated, the char depth. And just as a note, the NDS and the American codes use a nonlinear approach. So before going into the important changes to the IBC 2021, it's important to give a brief summary of the types of construction that's currently in the code. So currently we have non-combustible construction, light frame wood construction, and heavy timber construction, where the biggest changes has occurred in the IBC 2021. So type 1 and type 2 construction uses all non-combustible material like steel and concrete. The maximum height requirement can be from no requirement to 75 feet, or with like a 3-hour fire rating to a 0-hour fire rating. Type 3 construction is often used for multifamily light frame buildings, but given the height and area requirements you can see on the screen, larger light frame and post and beam structures can use type 3 construction. Type 5B is becoming a little bit more popular as a cost-effective way to create office buildings with a little bit more industrial feel. So for type 3, the exterior walls have to be made out of non-combustible material, but for interior elements, you can have any material as stated in the code. So if we just look at the inside of a typical office building, you can see that it's made of all wood. That's fine. For type 5, the structural elements, the exterior and the interior can be of anything, any material based on the code. So right here, the outside is all made of wood. In the new IBC 2021, type 4 is divided into 3 new categories. So 4A, 4B, and 4C. Code-wise, this is the biggest change in the wood industry, and it has a significant impact on the way we build with mass timber. Let's take a look at the height, area, and most importantly, the fire protection requirements. So for a type B occupancy, type 4A allows a building height up to 270 feet or approximately 18 stories. And then you can see for type B and C, the story numbers can be a maximum of 12 and 9. And the areas are listed here from larger to lower. So for the primary structural frame fire rating, type A requires a 3-hour fire rating, and type B and C requires a 2-hour fire rating. So we see that in the new codes, we need at least a 2-hour fire rating for all of our connections and our members. Non-combustible protection requirement is unique for the new type 4 categories. You can use gypsum boards to increase the fire resistant rating of the members and your connections. And these non-combustible protection requirements are a little bit different between the types A, B, and C. So for example, if you have a floor panel for a type A, you would need gypsum boards underneath that floor panel, above it, and you can also use a concrete topping. So for type A and B, you have to make sure that the non-combustible protection above the mass timber is at least 1 inch thick. So this slide sort of summarizes the main FRR requirements of these 3 categories. So type A doesn't allow for any exposed mass timber, and all of the elements should have non-combustible protection. Type B, you can have some exposed mass timber, but it's a certain percentage of the floor area. And then type C is the most lenient, where you can have exposed mass timber, but you have to remember you still need that 2-hour fire rating. And then other requirements include using sealant at the timber edges like we did for the beam hangers. There can't be any exposed mass timber in concealed spaces or exit ways and elevator shafts. And as a note, all the values I listed, so 18 stories, the areas, those are all assuming that you're using a fully functional sprinkler system. So to summarize, the new IBC 2021 allows for an increase in the building storing height using mass timber to up to 18 stories. The fire resistant ratings for these new type of buildings should be at least 2 hours. So we went over the drastic changes to the IBC 2021. Now let's just see how fire design is currently done and what important concepts we need to keep in mind for the example. So these are clearly summarized in the TR10, and the TR10 actually provides you some step-by-step procedures. It's now known that mass timber is naturally fire resistant, and it maintains its structural integrity through the char layer on the outside. It's right here, and we saw that before. So if you ever go camping and you decide to burn a big log all the way through, you'll see that's actually quite difficult, and that's because of this char layer here. Let's look at a typical charred wood member. If before the fire has started, you had an initial beam width of B and a beam depth of D, after the charring, the beam width will reduce to B char and the depth will also reduce to D char. So the science behind the char layer is that it's actually a function of time. So we mentioned before that it's nonlinear. So in the calculations and the char depth, we have to use the time, a reference nominal char rate, and a nonlinear char constant. So the formula is right here, and you can see where the char layer is on a burnt wood. So for a 1 hour fire rating, or sorry, for 1 hour fire, the HR is about 1.5 inches. And for 2 hours, it's more, it's 2.6 inches. Based on the TR10, to account for a reduction of strength and stiffness in the heated zone here, for structural calculations, you have to use an effective char depth. So the effective char depth is 20% more than HR. So this diagram is pretty neat. It actually shows you that heated zone and the charring of the wood here. So clause 4.5.1 of the TR10 states that connections for fire rating, it should be done so that the average temperature rise for the connector is limited between 250 Fahrenheit and with a maximum of 350 Fahrenheit. So the temperature for the heated zone is actually in between these two temperatures. However, that's not true for all the connections. There is actually an exemption in the TR10 for connectors that were tested in accordance to the ASTM standard. So right here. This exemption doesn't limit the temperature at the interface between the connector and the protection. So the charring temperature can be used. This is especially important for our beam hanger system. So the fire design and the testing were all used using the char layer thickness. Our other important concept is the corner rounding effect. If a rectangular beam is exposed from 3 sides, the charring is faster in the corners of the beam. And that's because they're subjected to heat transfer from 2 different directions. And this has a rounding effect. So right here you can see. So this was the original member, which was rectangular, but now it's rounded. So this is called the corner rounding effect, and the rounding R, so the distance from the connector to the rounding corner, actually has a value equal to the estimated char layer thickness. So my tip. So the blue areas here represent sections of the beam where it won't char in a 2-hour fire, so right here. You can see that it also includes the corner rounding effect. If you're using a narrow connector right here, the corner rounding is more important on the sides. So you can place the connector closer to the bottom. For a larger connector here, the corner rounding is more important at the bottom and less on the sides. Remember, if you want to use these connectors without reinforcement, you have to install them below the 30% line. So the red dashed line here again, we can see. As wood chars, it contracts. So in reality, the thickness of the char layer is less than the depth of the wood that has chars. Char contraction at unbonded wood members, ends, and edges is especially important. So right here, if we have two members, they're unbonded, it's super important because it results in the ignition of the wood surface in the gaps, so here. So the ignition extends into these gaps at twice the char depth. We'll later see in the example how that actually affects the fire design of your members. To recap, the TR10 is basically an appendix to the NDS. It provides step-by-step procedures for the fire design of the members and connections. And we need to remember three things: the char rate, the corner rounding effect, and the char contraction at gaps. Now let's jump into that example that I've been talking about throughout this whole presentation. I know we'll finally hear. We have a simple post and beam structure subjected to a fire. So we're only going to do the fire design of the connections, and then we're going to compare the requirements for a standard connection like this bearing plate here to the beam hanger system here. Example 1 and 9 of the TR10 does a 1-hour fire rating for a connection of a simply supported beam. The beam size in that example is 6 3/4 inch by 13.5 inch deep. To be consistent, we're going to go over the same example, but for a 2-hour fire rating. There is an applied moment of 30,000 pounds and a shear of about 7,000 pounds. And another note is that all of this design is based on the NDS. For the fire check, we have to make sure that the structural elements are able to take the applied loads. We can check the section modulus and the shear area. For a 2-hour fire rating, we see that the section modulus isn't enough, so the beam is actually small. So we need to increase the beam size. So based on available glue lamp sizes on the market, we chose a new beam size of 8 3/4 by 18 inch deep. And we did all the calculations. It's clear that the beam, even with the reduced char thickness, has enough capacity for the applied loads. So we're good. The standard connector that was used in the TR10 is a 3.5 inch wide by 0.3 inch thick internal bearing connector. For this new beam size, we can definitely use a bigger connector, but for simplicity, we're just gonna use what's in the example. So when you place your connector, you need a char cover at the bottom, and that's governed by the notch depth. So the maximum notch depth for this 18 inch deep beam is 1.8 inches. If we provide a wooden plug at the bottom and calculate the time that this wooden plug can handle in a fire, we see that it's about 63 minutes. And that's not enough for our 120 minutes. So we need additional cover at the bottom of the beam. So I'm just gonna go over quickly one important clause in the TR10, and that's clause 4.4.13. That says if multiple layers of wood are used in the protection time, the last layer should be multiplied by 0.85. So here we assume that we won't need another layer. We do the calculations and we see it's still not enough. So we need more wood cover. We also have to check if there's cover needed on the sides of the connector. After you plug in the holes for the bolt, we see that the wood cover on the side of the connector is not enough for 120 minutes. So you have to do the calculations again, and you have to add extra wood cover. So I mentioned that char contraction is important at unbonded gaps between the wood members. We saw that the char contraction ignition at the gaps, so here and here, can propagate to a depth of 2 times the char thickness. If we add more wood cover on those corners, we see that the char contraction here can be less. So again, we have to calculate the extra pieces of wood that we need for the corners right here. So for the bottom, we'll need another piece. And then for the sides, we'll need 2 other pieces. So these 2 figures show the top and side view for the fire design of the internal bearing connectors. For the bottom of it, you need 2 pieces of 2x8, and you'll need one piece of 2x2 for that char contraction. For the sides, you would need 2 pieces of 2x8 again, and then you would need 1 piece of 2x2 on each side. And that's a lot of stuff you have to add. So now here, we're going to do the fire design again for that 8 3/4 by 18-inch deep beam using the beam hanger. If we go into the beam hanger design guide and look at the selection tool, we can see for our 7,000 pound shear load, we can choose the Rikon 200 by 60. So the important features of the beam hanger are summarized here. These are the features that helps with selecting the right connector for your project. And these connectors are tested and included in the exemption from that clause 4.5.1 in the TR10 we mentioned. So if you look, you'll see, oh, it's actually certified fire rated. So perfect. The fire design section of the guide is pretty simple. For a 2-hour fire rating and for the connector that you choose, you'll need a minimum of 8 by 5/8 of an inch wide beam or 17 1/4 deep beam. Just as a note, make sure you have the right spacing as mentioned in the table. It's designated right here as A sec or A min. It's also important to note that these values are based on the testing done in the United States. By providing sufficient wood cover that's more than the char thickness, we can easily have a fire-rated connection. And it's important to have fire caulking around the connectors, just as we saw from the testing. So to wrap up our example, let's compare the fire design requirements for a standard connector to the beam hanger system, side by side here. So for both custom and standard connector, you need a wood plug at the bottom. So it's added right here. For the standard connector, you need to calculate to see if you actually need additional wood covers at the bottom. For this one, you needed more. You have to make sure that it's tightly screwed in and the screws have enough length to keep that protection in place. We did the calculations again and we needed another piece. and you have to screw that piece again. If you see here, you see that the beam hanger really hasn't changed much and you hadn't add anything there. For the char contraction, you have to make sure you're screwing on a little piece of wood again. And you'll see for the bottom, you have a lot of wood pieces attached. You have to repeat that step again for the sides of the connector. You'll see for the beam hanger, you don't need to use any wood plugs as you do compared to the standard connector here. So after providing that wood plug, you'll have to provide additional cover. You have to screw that additional cover. And for the char contraction, you would have to provide more wood pieces and also attaching those wood pieces correctly. And from all of this, you can see that the fire design is really complex. And that's in addition to actually designing the connection itself. So to conclude our presentation, I'd like to mention that with the recent code changes, MightyCon is always looking to improve its connection systems. We're very dedicated in doing testing on all of our products, and that includes doing additional fire testing for our beam hangers and, of course, obtaining an ICC approval for them. So stay tuned for exciting updates. One thing before we leave, I'd like to mention that we have technical learning sessions provided, and those are done by the engineers here, like myself, and there are 4 engineers and architects. So if you're interested, you can click on the links that's in the chat. I also like to show it to you if I can bring up the chat right here. So the technical learning sessions are pretty simple. It's done online, and you can see here, all you have to do is provide your email and your name, and we'll set up a time. Very briefly, WoodWorks and American Wood Council have really great white papers and technical documents for fire design and also the recent code changes. So if you ever want more information, you can also refer to them. And obviously our white paper on fire design for our beam hanger connections. So that's it for me. Thank you so much for attending the presentation today. We'll wait a few minutes and then I'll look over the questions. Thank you.
Thank you again for joining us today. As a reminder, you will receive an email on Monday with a recording of the session, slides, Q&A, as well as the survey where you can get your certificate of attendance. If you have any further questions, you can contact us at info@mightycon.com. That's info@myticon.com. Thanks, guys.
So I see a question about our ICC report. So as my colleague Dominic mentioned, they're not ICC approved yet. For these new beam hanger types, it's harder. It takes a bit of more time for the approval. But if you ever want to consider using the Rikons or the Megants, you can use them in the US by providing building officials with the proper set of documentation and research. You can definitely reach out to us and we can help you with that. So the other question is about the fire caulking. That depends on how you're housing the configuration. But we mentioned the fire caulking because that was what was used in the testing, and that's how the testing and results were from. In Europe, they actually, if 2 elements are connected, They're considered to be bounded if they have gaps that are smaller than 2 millimeters, so they're a little bit more lenient there. So other questions are asking if it was certified for 1.5 hours, how we did the 2 hours. So it was certified for 1.5 hours, but the 2 hours in the tables were actually using the NDS and the codes. And again, I mentioned by providing enough char thickness and wood cover at the bottom, you can achieve that 2-hour fire rating. And you don't need to add extra wood members. So there's an interesting question. Is there any study being made for the use of these connections in tropical weather areas? Not that I know of right now. You have to make sure that the screws used are for wet surfacing conditions. If you do open up our guides, it's actually mentioned, but nothing in particular that we have done specifically for tropical weather areas. All right, it doesn't seem to be any new questions coming in. Just as a quick note again, the ICC is currently pending for these connectors. But again, if you would like to use them, they've been used throughout the US and Canada extensively, and we'd be happy to help you work on your projects and provide the research and documentation that you need for the approvals from the cities. So I think that's it for this presentation right now. Again, thank you so much for attending. We hope you tune in to our future webinars and remote learning sessions. Thank you.
If you have any more questions, feel free to ask them now, and we will send the answers to those in the follow-up email.